Alright guys, topic 5 is on slant hyperbolas, and as I said, I will be offering an extra credit problem on the test if you can graph a slant hyperbola and maybe just know a little bit about them. So I'm going to start with some examples, and the first example I want to talk about is this example right here. xy equals 8. Okay, so the first thing I want you to do is I want you to think of several xy pairs that work in that. Two numbers that multiply to make 8. You know, maybe we could pick 2 and 4, or 4 and 2. Okay, so then graph those. So what are some other numbers that multiply to make 8? Maybe you thought of 1 and 8, or 8 and 1. And when do you graph those? Okay. So whenever you're doing this kind of exercise in math and you're thinking of numbers that multiply or, to make 8 or work to meet any pattern, I would recommend that you don't just think of positive whole numbers. So let's think of maybe some negative numbers that multiply to make 8. Maybe negative 2 and negative 4, or negative 4 and negative 2. So let's plot those as well. And again, we could have chosen negative 8 and negative 1, or vice versa. Okay. And so what we end up with is we could come up with an infinite number of points. You could come up with all sorts of points, and when you graph them, you end up getting a hyperbola that's shaped something like these. It has two asymptotes, and the asymptotes are basically the axes. So it's x equals 0 and y equals 0. If we think about the line of symmetry, this is the line of symmetry. And the line of symmetry is the y equals x line. And so it's just a different type of hyperbola. So I wanted to do another example. So, if you could, why don't you try the same thing for x times y equals negative 8. So let's think of several pairs. And again, we can use the very similar pairs to above, but instead of positive 2 and 4, it would be negative 2 and positive 4, or positive 4 and negative 2. Conversely, we could have positive or negative 4 and positive 2, or positive 2 and negative 4. All of those numbers are numbers that multiply to make negative 8. So if we graph all these, not that one. And then we can go with negative 1 and positive 8, negative 1, positive 1, negative 8, negative 8, positive 1. And we can graph all those. And we end up with a very similar, what we call slant hyperbola. It's a hyperbola, the asymptotes again are the x and y axis. So the asymptotes are x equals 0 and y equals 0. Okay? But let's talk about that line of symmetry, because in this case the line of symmetry runs in this direction. And so the line of symmetry here is the y equals negative x line. Okay? So in the next page,